Okay guys, so we'll be seeing more on the calculation of entropy change in this video lecture. So let's get started. So suppose we have H2G reacting with half moles of O2G and converting itself into H2OL. So delta RS naught or delta FS naught for this reaction can be written as delta RS naught would be equals to entropy of formation of H2OL minus entropy of formation of H2OG minus entropy of formation of O2G. So we can write these two values as 0 and directly delta RS naught can be written as delta F S naught of H2L. Okay, and why is this the case? This is not H2O, this is H2G. Okay, so similarly as we saw in case of delta F of enthalpy for elements and for substances that are found naturally occurring in the nature, so we can write delta F S naught as 0 for these type of elements. Hence delta F S naught for H2G was 0 in the previous case, and similarly delta F S naught for O2G was also 0. Okay, but on the same hand delta, rather not delta, molar enthalpy at standard states for O2G would not be equals to 0, and let's say some another element would also be not equal to 0. Okay, so if we write, so first of all this is half here, we have to also include the stoichiometric coefficient of O2G here. Okay, so if we write delta RS naught in terms of molar entropy, then it would be SM naught H2OL minus SM naught H2G minus half of SM naught O2G. Stoichiometric coefficient for SM H2OL and H2G was 1 and 1 here, so we didn't write. But in case of O2G, stoichiometric coefficient was half, so we are just multiplying that with SM naught. Okay, similarly let's take another example of reaction of carbon monoxide gaseous plus half moles of O2G converting itself into CO2G. So in this reaction again delta RS naught can be written as delta FS naught carbon monoxide carbon dioxide minus delta FS naught or entropy of formation of carbon monoxide. As mine, there would also be another term minus half delta Fs naught O2G, but that would be considered as 0 because this is in elemental form. Okay, so if you see it like this, then let's suppose we have carbon S graphite reacting with O2 to form CO2. So here we can write that delta R SR naught, or let's say SF naught itself, SF naught CO2G can be written as SM naught CO2G minus SM naught COG minus SM naught O2G. Oops, it is not COG, it is rather graphite. Okay, and let's say this was the first reaction, and the second reaction is, suppose we have again CS graphite reacting with half mole of O2G and converting itself into carbon monoxide. So in this reaction we can write that delta F delta R SF delta F of the reaction would be equals to let's have this delta R SF naught for COG can be written as SM naught COG minus SM naught CS minus half of SM naught O2G. Okay, so first let me write it here clearly that it is delta S formation of CO2G, or it can be written as delta R S naught for this reaction. Similarly, this is delta formation of delta naught formation of COG, or this can be written as delta R S naught for this reaction. Now if we actually look into this, so if we subtract the first reaction from the second reaction, or in other words, if I write carbon as graphite plus O2G converting to CO2G, and write the second reaction in inverse, which is COG plus COG gives carbon as graphite plus half O2G, and add them, then I think we will get this reaction that COG plus half O2G gives us CO2G. Okay, and this was the initial reaction which we were talking about, which was this. Now we want to derive this equation from these two reactions. Okay, so for the first equation we had, or for the final combined equation, which is 1 minus 2, we can write delta R S naught would be equals to just writing this and negating this from this, so it would be SM naught CO2G minus SM naught CS minus SM naught O2, so it would be SM naught CO2G minus SM naught this is not delta, minus SM naught CS minus SM naught O2G, and subtracting this term from the second equation, which was this one, which is SM naught COG minus SM naught CS minus half of SM naught O2G. So SM naught COG minus SM naught Cs minus Sm naught, half of Sm naught O2 G. So if we subtract that, then we will be getting, you can see that this Sm naught Cs and this Sm naught Cs will get cancelled out. We'll get Sm naught CO2G minus Sm naught COG, and this would be, or rather minus half of Sm naught O2 G. Okay, so this would be the SR naught for the final reaction. Okay, so here we have mentioned it in terms of delta F S naught. Okay, but we can also write it in terms of Sm naught. So we have seen that S delta R S naught would be equals to delta F S naught CO2G minus and delta F S naught COG. So delta F of entropy of formation of carbon dioxide would be this, in which we looked at this reaction in which CO2 gas was getting produced or formed, and delta F of carbon monoxide would be this coming from the second reaction, like this. And finally we subtract entropy of formation of carbon monoxide from entropy of formation of carbon dioxide, and we will get like this. Okay, so this would be the entropy of the reaction of formation of carbon dioxide from formation of carbon dioxide from carbon monoxide. So this would be the entropy of the reaction. So with this we come to the end of this lecture. In the next lecture we'll be seeing the variation of entropy of reaction with temperature, and then we'll be seeing reversible ideal gas expansion or compression. So till then, good luck and goodbye.